Calvin, it's Crazy Hat Day, not Mask Day. Oh, does that work as a hat?
Uh-huh.
Okay. Well, I don't think I can wear this hat the whole time I teach. So since we're doing a lesson that I consider to be the OG of solving quadratic equations, I'm going to put my old grandpa jacket on and my OG hat. Pretty crazy hat, don't you think? Or is your dad just crazy?
Your dad's just crazy.
Your dad?
Yeah, my dad.
All right. Later, dude. Get out of here! All right, welcome back. Today in our virtual Spirit Week, it's Crazy Hat Day. I know it's not the craziest stuff you've ever seen, but what is crazy is I got a joke from a student the other day. They're like, hey, use my joke. I was like, all right, I got you. So, why don't seagulls fly over the bay? That's right, because then they'd be called bagels. Bagels. I'm actually kind of hungry. That sounds good. Anyway, moving on. All right, so we're going to start out by solving using any method. So at this point, we have three different methods. We have solve using square roots, we have solve by factoring, and we have completing the square. So this first one, you might actually recognize that we could factor it pretty easy using difference of two squares, but it's also a good example of when we could use the square root method, because we have x squared by itself, there's no b value, and we could easily move this 16 to the other side. So x squared equals 16, and then because we didn't have a b value, when we take the square root, we can just take the square root and get a nice, easy answer of plus or minus 4. So again, we could have factored it and gotten x plus 4, x minus 4, and then set each of those factors equal to 0, and we'd still get the same answer. So we have multiple ways for some of our problems for how to solve them. The second one, this looks like one that I could factor, so I'm going to try factoring. First term, first box. Last term, last box. The two unknown boxes have to add to 8x. And then they have to multiply to 15x squared. And yeah, that'll work, right? Multiplies to 15, adds to 8. We can do 5x and 3x. Take out our common factor of the top row. Multiply around the outside. Double check. 3 times 5 is 15. That factored. Beautiful. And so we could set our factors. X plus 3 times x plus 5. Set that equal to 0. And then hopefully you remember, once we've set our factors equal to 0, we take our first factor. We set that one equal to 0. Solve it. X equals -3. And then we can take our second factor and set that one equal to 0. So x plus 5 equals 0. Subtract 5, and x equals -5. So solve by factoring, factor it, set it equal to 0, solve each factor. And then this one looks like it can be factored too, right? So I'm going to try factoring. I'm pretty good at factoring. I kind of like it. It's like a little puzzle. Need to add the positive 6x. Hey, pipe down back there, Calvin. I'm trying to teach. And then these multiply to -1x squared. But, that does not, I can't think of anything that multiplies to -1 and adds to 6. So if it looked like it was factorable, I tried factoring, and that's good, but I can't factor it. So at this point, what did we try? That's right, this is where we went to complete the square. So to complete the square, I'm going to move the c value to the other side. I'm going to rewrite it as x squared plus 6x plus blank equals 1 plus blank. Bring down my square. First term, first box. We don't know what the last term is yet, but we know that these two terms have to add to 6x, and we want them to be the same. So we split the 6 in half. We take out our common factors, and we get x plus 3 times x plus 3, which means our new term has to be 3 times 3, which is 9. So we're going to add 9 to both sides, which allows us to then rewrite the problem as x squared plus 6x plus 9 equals 10. This is now a perfect square, x plus 3 squared. This side is still 10. Take the square root. X plus 3 equals plus or minus square root of 10. I know square root of 10 does not simplify because the only factors are 5 and 2. And then subtract 3 on both sides. X equals negative 3 plus or minus square root 10. So again, if it looks factorable, I would encourage you to try to factor it. And if it doesn't factor, then you can complete the square. Now this next one might look familiar. This is the problem that we ended with yesterday. So x squared plus 7x minus 14. It was the one that I said does not factor. I can try to factor it, but it doesn't, I promise. And then why did we say completing the square would be a bad idea for this problem? That's right, completing the square would not be a good idea because when we split the middle, we're going to get a decimal, which we could do, but we're not going to. So this is where we're going to introduce our fourth and final method, which is kind of your one-stop shop for solving quadratics. Because the way that I'm about to teach you next is actually a method you can use for every problem we have done so far when we're solving a quadratic equation. So if you're going to learn one method, the one we're doing today is like, hey, if you learn this, you can solve every problem. So why didn't we start with this one? Well, a couple of reasons. One, we wanted you to know how to factor, because you factor a lot in your future math classes. But two, you'll find out hopefully by the end of this lesson that the quadratic formula, although wonderful, it's kind of a lot of work. So some of these other methods like square root method, factoring, they're quite a bit shorter, and so they become kind of an easier method on some problems. But there are times where those methods don't work, and we have to go to the granddaddy of them all, the quadratic formula. All right. So the quadratic formula can be used anytime for any quadratic equation. Specifically, I would use it when the other methods don't work or are proving to be too difficult for you. That is where we go to the quadratic formula. So you might be looking at formula and thinking, wow, that is a really big formula. I could never memorize that. Well, have no fear. Mr. Dresser is here. We are going to play a song, and then there's a good chance if you're in my class, you're going to be singing this song back to me at some point. So let's go ahead and get started with the memorization of the quadratic formula. If I can get my internet to turn on, there we go. The quadratic formula. Quadratic formula. Quadratic formula. The quadratic formula.
To solve any quadratic equation, all you need is the quadratic formula. Here's a little song to help you remember it to the tune of Pop Goes the Weasel. Me, 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 me.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
X equals a negative b and plus or minus the square root b squared minus 4ac all over 2a.
X equals negative b plus or minus the square root b squared minus 4ac all over 2.
X equals negative b plus or minus square root of b squared minus 4ac all over 2a.
X equals negative b plus or minus square root b squared minus 4ac all over 2a.
man, that's the best song ever. And also, I didn't find a bagel, but I found the rest of a chicken nugget. That's good. So, what are A, B, and C, and how do we actually use this? Let me finish my chicken nugget, and then I'll tell you. All right. So, when we talk about the A, B, and C in the formula, the A, B, and C come from standard form of a quadratic equation. So the term in front of your x squared is your A, the term in front of your x is your B, and your constant is your C value. But notice that it does have to be equal to 0. So if this is not 0, you're going to add or subtract that number and move it over to the left side. So to use the quadratic formula, we're going to identify our A, B, and C. We're going to plug our A, B, and C into the quadratic formula, and then we're going to simplify. So that problem that we left off with yesterday and the problem that was the one on the warm-up today, we can now solve it. So again, first thing, equal to 0. Good. Identify A, B, and C. So our A is whatever number is in front of our x squared, which if there's nothing there, we know that that's really a 1. All right, so our A value is 1. Our B value is in front of the x, so that's 7. And then our C value is our constant. We have to make sure we look at the sign, so that is a negative 14. And then we're going to plug it into the formula. So you're going to get used to hearing me not quite sing it, but just kind of, use the tune a little bit. So x equals negative b, 7, plus or minus the square root b squared, 7 squared, minus 4, oh man, AC, A is 1, C is negative 14, all over 2A. So 2 times A, which is 1. So there is our quadratic formula. We've plugged in our A, B, and C into the correct spots. And now we are going to simplify. So x equals negative 7 plus or minus the square root of 7 squared, so 49, minus 4 times 1 times negative 14. Here's a spot where people make a lot of mistakes, so you got to be careful. I have minus, and then I have a negative. So if I have minus a negative, or negative times a negative, that's going to turn this into positive. 4 times 1 times 14 is 56. All over 2 times 1, which is 2. All right. X equals negative 7 plus or minus the square root. We're going to add these together to get 105 over 2. And then to fully simplify it, we always look to see if we can simplify the square root. So square root 105. I can do 5 times 21. I can do 3 times 7. Are any of those partners? They're not, so we actually cannot simplify this. And this is our final solution set. We have negative 7 plus square root of 105 divided by 2, and negative 7 minus square root of 105 divided by 2. That is the quadratic formula. All right, so here's some more examples. First thing, make sure it's equal to 0. Second, identify your A, B, and C. And then we're going to plug those into the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac. So 3 times negative 5 all over 2a, 2 times 3. Calvin, be quiet. X equals negative 2 plus or minus the square root. 2 squared is 4. Once again, we have minus and then a second negative. So 2 negatives make plus. 4 times 3 is 12. 12 times 5 is 60. All over 2 times 3. So again, we're going to simplify the square root. X equals negative 2 plus or minus square root of 64. And then square root of 64. This time we actually get one that is a perfect square. Negative 2 plus or minus 8 over 6. And all that means when we find one that has a perfect square, it actually means that this problem was factorable. We could have factored it, but it's perfectly fine. We're still going to get the exact same answer as if we had factored it. At this point, we can either do negative 2 plus 8 divided by 6 and negative 2 minus 8 divided by 6, or I'm going to introduce you right now to a very mathematical term of the nacho chip, which is something that a student last semester actually had the idea of using, and it's a pretty good idea. So when we get to this point of the quadratic formula, if you have in these 3 spots, kind of looks like a Dorito chip, right? Dorito, not nacho, Dorito chip.
I like Doritos.
Calvin, seriously, be quiet. If you have 3 numbers that can be reduced, you can reduce this right here. So if we have 2, 8, and 6, all of those can be divided by 2. So I'm going to rewrite this as negative 1 plus or minus 4 over 3. So we can simplify it. And then to get our 2 final answers, we're going to do negative 1 plus 4, which is 3, divided by 3. 3 divided by 3 is 1. Our second answer would be negative 1 minus 4, which will be negative 5 divided by 3. So negative 5 thirds. So again, when you use the quadratic formula, if you get a perfect square right here, then it means we're going to be able to simplify all the way down to our 2 solutions. All right, next problem. Why can we not use the quadratic formula yet? That's right, we need this to be equal to 0. So I'm going to subtract 1 on both sides. 4x squared minus 4x minus 1 equals 0. Now that it's in standard form, we can use the quadratic formula. Identify our a, which is 4. B is not 4, b is negative 4. And then c is negative 1. Plug those into the formula. X equals negative b plus or minus the square root b squared. This is where you want to be really careful and use parentheses. It's a negative 4 squared, and I'll explain why in a minute. Minus 4 times a times c all over 2a, so 2 times 4. And then as we simplify it, negative 4 just becomes a positive 4, plus or minus the square root. If you forget to use the parentheses here, you might accidentally put negative 16. It happens all the time. But if you put it in parentheses, that's your reminder, and also if you plug it in your calculator with the parentheses, it'll give you the right answer. Negative 4 squared means negative 4 times negative 4. 2 negatives always multiply to make a positive. So when you're simplifying the quadratic formula, you never get a negative number at this front spot. The b squared will always be positive. And then we have minus 4ac, which again, this one we also have 2 negatives, so it's going to turn into a plus. Not every problem will have a plus here, sometimes it will be a minus, but so far we've had problems where we've had 2 negatives. And then 4 times 4 times 1 is 16, all over 2 times 4, which is 8. Continue to simplify. 4 plus or minus square root of 32 over 8. Don't look for the Dorito chip yet. We have to simplify the square root first. Square root of 32 does simplify. 2 times 16, 2 times 8, 2 times 4, 2 times 2. So wow, we get a lot of 2's. We can rewrite this as x equals 4 plus or minus. I've got 1 pair of 2's and a second pair of 2's. So 2 times 2 is 4. And then I have 1 2 left over. So square root 2 over 8. almost done. This is where we look to see if we can simplify. And I look at that little Dorito chip idea. I'll use a Cool Ranch Dorito on this one. We'll go with the blue. 4, 4, and 8. We ignore the square root 2. We pretty much treat it like a variable. This will not change. We won't reduce it. It's going to stay square root 2. But we can divide each of these by 4. So instead of 4 out front, 4 divided by 4 is 1. Instead of 4 square roots of 2, if we divide that by 4, we're going to have 1 square root of 2. And then instead of 8, 8 divided by 4 will be 2. So this simplifies to 1 plus or minus square root of 2 over 2. This is as hard as they get. This would, in my opinion, this would be an example of the hardest type of quadratic formula because we were able to simplify our radical into something else, and then we were able to reduce it at the end. So it kind of had everything we could throw at you in one problem. So hopefully you're doing okay. Let's go ahead and not go to that slide. No, we are going to that slide. All right, so here we go. We're going to solve some more. Just a reminder, when we're finding the solutions, it's really our zeros, roots, or as you'll find out when we get back from spring break, we also call these our x-intercepts, which is going to be one of the more important things we use the quadratic formula for, is to find the x-intercepts of problems. But anyway, a is 3, b is 5, c is -8. Plug them into our formula. X equals -b plus or minus the square root b squared minus 4 times a times c all over 2a. And then we simplify. -5 is -5. 5 squared, 25. Minus a negative, it's going to turn to plus. 4 times 3 is 12. 12 times 8 is 96. All over 2 times 3. Go slow when you need to, use your calculator. And as I continue to simplify this, I get x equals -5 plus or minus the square root of 121 over 6. 121 you might recognize as a perfect square, which means this one would have been factorable. -5 plus or minus the square root of 121 is 11 over 6. If I try to reduce with the Dorito chip, those do not have a common factor, so I can't reduce it, but I can separate this into 2 separate answers. I'm going to do, and I'll show it this time, -5 plus 11 divided by 6. And our other one is going to be -5, but this time minus 11 divided by 6. So -5 plus 11 is 6. 6 divided by 6 is 1. So one of our solutions was 1. And then -5 minus 11 is -16 over 6, which we can reduce that, so we're going to go ahead and reduce that, which ends up reducing to -8/3. So again, our final answers for this are x equals 1 and -8/3. All right. Next quadratic formula problem. Why is this not ready to be solved? Because this x needs to go to the other side. So when I subtract x, I have to be careful because x is my b part of standard form. So when we rewrite it, this -x needs to go after the x squared, but before the plus 7. Right? So I'm putting it into standard form. And then this is 0. Identify our a, b, and c. A is 2, b is -1, c is +7. And now we can plug it in. X equals -b, negative, plus or minus the square root b squared, -1 squared, that will be a positive, minus 4 times 2 times 7. All over 2a, 2 times 2. X equals positive 1 plus or minus negative 1 squared. Negative 1 times negative 1 is positive 1. A minus, and then notice this time there are no more negatives. So we're not going to switch it to plus. It's going to stay minus. 4 times 2 is 8. 8 times 7 is 56. All over 2 times 2. As we continue to simplify, we get x equals 1 plus or minus square root of negative 55 over 4. And at this point, hopefully you're going, wait a second, square root of a negative number. I thought we couldn't do that, right? Unless we use our imagination, right? Imaginary numbers, which we're not going to go into too much yet. Other than to say, if you get this, we know that we don't get a real solution, right? So square root of a negative, if you plug it in your calculator, it's going to say no solution, or it's going to say error. So at this point, we can stop the problem, and we know that we get no real solutions. No real solutions. The reason we say no real solutions is because there are imaginary solutions. I know it sounds a little crazy, right? But there actually are 2 imaginary solutions for this problem, and this will be on your homework. Anytime a quadratic has no real solutions, it also means you will have 2 imaginary solutions. But in IM2, we're not going to make you find the imaginary solutions. We're just going to say, hey, there are no real solutions, and down the road you can figure out how to find the imaginary ones. So, to summarize, key point. Square root of a negative, can't do it yet. No real solution. All right, checkpoint. Your turn to try. Go ahead. All right, welcome back. Hopefully you did okay with this one. Let's go ahead and review it. It's equal to 0. That's good. Our A is 1. B is negative 3. C is negative 2. Plug it into the quadratic formula. X equals negative 3 plus or minus the square root B squared minus 4 times A times C all over 2A. Hopefully you're starting to get that song stuck in your head, because if not yet, you will, I promise. X equals negative 3, which is a positive 3, plus or minus the square root of negative 3 squared, which is a positive 9, minus times a negative is going to be plus. 4 times 1 times 2 is 8. All over 2 times 1, which is 2. As we continue to simplify, we get x equals 3 plus or minus the square root of 17 over 2. I try to simplify the square root of 17, but it is a prime number.